Hello, welcome back to Cardinal Science. In this video, we'll be looking at alkanes. So the specification points 4.19 to 4.22 are those that are relevant to alkanes in this specification. So we need to know the general formula, we need to be able to explain why they're saturated, be able to draw them in both structural and displayed formulae, and name them, and then describe their reactions with halogens. So for 4.19, we need to know the general formula of alkanes. Now I have covered this in a previous video, however, since we're doing alkanes now as a whole topic, I'll cover it again. So an alkane is a chain of hydrogen and carbon bonded together, only containing single bonds. So the first three alkanes look like this. So the first one is methane. It contains one carbon and has four hydrogens bonded around it. Now each carbon in these chains can only bond 4 times. So that's of course 4 single bonds. If there are double bonds, then those count as 2, and we'll see those when we look at alkenes. Now the second in this group of hydrocarbons is called ethane, and that one contains 2 carbons. Now you'll note that each carbon in this case is only bonded to 3 hydrogens because of course there's a single bond in the middle. So each carbon is bonded 4 times. Now when we move to propane, the third one, you'll see that what we do is we actually just add a CH2 group in the middle. This is important because as we move through the alkanes, each time we just add one more CH2 group. So butane, for example, would look like this. Butane has 4 carbons in it. On the first one, we're going to have 3 hydrogens bonded. And of course, at the other side of the chain, we're going to have 3 hydrogens. And in the middle, we're going to have 2 CH2 groups. So where with propane, we had 1 CH2 group, we now have 2. If we went to pentane, we'd have 3. Despite the fact that it's possible now for us to just keep adding CH2 groups to figure out the structure of any alkane, we can use what's called a general formula to help us with this, especially with very large chains. So if we look at the symbol equation for these first 4 alkanes, you can see that methane is CH4, then you've got ethane, which is C2H6, propane is C3H8, and butane, which is C4H10. Now, what we need to see here is that there's a pattern in the number of carbons versus the number of hydrogens. Okay. Now, what we might notice is that in each one, the number of carbons we can use to calculate the number of hydrogens by multiplying it by 2 and adding 2. Okay, so let's try this. So for the first one, methane, we have 1 carbon, and we times it by 2, and we add 2, and that gives us 4, which is the number of hydrogens. And if we try the second one, the number of carbons that we've got is 2, multiply it by 2, add 2, that gives us 6, and we can keep going. So therefore, we can predict, for example, the number of hydrogens in pentane, in hexane, and in C15. Now, if you want to pause for a moment and have a go, use the formula below to figure out how many hydrogens there are in each of those molecules. Okay, so let's give it a try. So we've got 5 carbons, multiply it by 2, and add 2, so that's going to be 12 hydrogens. For C6, we're going to do 6 times 2, we're going to add 2, and that's going to give us 14. And for C15, we're going to do 15 times 2, which is of course 30, and add 2, and there should be 32 hydrogens. So you can see that as the carbon chain gets longer, we can figure this out using the general formula, which saves us a lot of time. So for point 4.20, we get introduced to a new term, saturation. Okay, so when we talk about things being saturated generally, we mean things that are full up, that they can't hold anymore. And you'll have come across this term earlier on in the course when we were talking about solutions. A saturated solution, if you remember, cannot contain any more solute because it's already gotten as much dissolved in it as is possible at that temperature. With regard to hydrocarbons, what we mean by saturated is that it consists of only single bonds. So alkanes are all saturated because they can't form any more single bonds, they're full up. So this alkane on the left here, okay, propane, you'll see that each carbon has got 4 single bonds. There's no more capacity for any more single bonds. However, this alkene on the right we refer to as unsaturated. Now we'll cover this when we do alkenes, but just for comparison I'll show you now. It is possible, of course, that these 2 carbons could hold more hydrogens if that double bond was broken. Therefore, we consider this to be unsaturated. Again, there's a bit of overlap here with what we've covered previously, but we'll go through it again just in case you haven't seen that video, though I would recommend going back. Okay, so how do we name alkanes? Well, like with any hydrocarbon, we use the number of carbons to identify a prefix. So for these prefixes down the side here, this will be 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. So if there's a 1 carbon chain, we call it meth, or rather that would be the prefix, then eth, prop, bute, and then pent, and then hex if it's 6. Now, for alkanes, the way we recognize an alkane in its name is that it ends in ane, ane. So when we're naming them, we look how many carbons there are, and if it's an alkane, we add an ane on the end. So we get the name methane for the first one, which is of course CH4. We get ethane for the second one, C2H6. Propane for the third one, C3H8. Butane for the fourth one, C4H10. And then pentane for the fifth one, C5H12. And you can see that the general formula that we've been applying fits here. Now, we also need to be able to draw structural and displayed formulae for all of these. Now remember, structural formulae shows how many hydrogens there are bonded to each carbon, and the displayed formula shows all of the covalent bonds in the molecule. So let's do these one at a time. So the structural formula of methane is just CH4. We've got 1 carbon with 4 hydrogens bonded to it. In ethane, we've got 2 carbons, and each one is bonded to 3 hydrogens. So we get CH3, CH3. In propane, we get CH3 on the first carbon, then we get our first CH2 group, then we get a CH3. For butane, we've got 4 carbons, and you can see the pattern continues. We start off with a CH3, we add a CH2, a second CH2, and then a CH3 on the end. And pentane is one larger, so it's CH3, CH2, 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 and ending with a CH3. Now, for each one, for the displayed formula, we need to show the covalent bonds. So, for methane, we draw our bonds in and our hydrogens, CH4. For ethane, we've got 3 bonded to each of the carbons. For propane, we've got 3 carbons, and we could draw our hydrogens in. Get very tired of drawing hydrogens doing this, but it's very important. For butane, we've got 4 carbons, so 2 CH2 groups in the middle, and we've got 10 hydrogens in total. Okay, and finally pentane, we'll have 5 carbons, CH3 on either end, and CH2 groups in between. And there you have it, the structural and displayed formula for the first 5 alkanes. Finally, for 4.22, we need to be able to describe the reactions with halogens. Now remember, a halogen is a diatomic molecule, so it consists of 2 atoms bonded together from group 7 in the periodic table. So that's fluorine, chlorine, bromine, iodine, etc. Now alkanes are particularly unreactive, so we have to use ultraviolet light to provide enough energy to get this reaction to happen. Now regardless of which halogen you use, the reaction occurs in the same way. So what you have is you have your alkane and you have your halogen, and then what happens is one atom from that diatomic molecule gets substituted for one of the hydrogens on the alkane. As you can see here, we've replaced this hydrogen with the chlorine, and the hydrogen has come off and it's bonded to the remaining chlorine, forming hydrogen chloride, or HCl. That's why we refer to it as a substitution reaction, because we've substituted one of the hydrogens for a chlorine. Okay, so let's do this with a bit of color coding to help. So I've got a chlorine molecule here with 2 different chlorine atoms, and the hydrogen that's going to be substituted. Now, what we do is we substitute one of these chlorines with one of these hydrogens, this one right here, and then of course your chlorine ends up on here, and that hydrogen has been swapped with the chlorine and is now bonded to the other chlorine, so your red hydrogen now is bonded over here to the chlorine, forming the HCl. So you can see you've swapped one of the chlorines with one of the hydrogens. Now for good practice, we're going to make sure we can also do this with regard to word equations and symbol equations. I've been showing you a displayed formula so far for the organic molecules just so you can see where the atoms are going. However, when we're doing a word equation, it needs to look slightly different. So this is of course ethane, and we're reacting with chlorine. And what we make is something that we call chloroethane. So chloro because there's a chlorine on it, and ethane because it's essentially an ethane molecule. And then we get hydrogen chloride. Notice that the naming, we react with chlorine, so we get chloroethane and hydrogen chloride. If we were to be reacting ethane instead with fluorine, we would get fluoroethane and hydrogen fluoride, or bromoethane and hydrogen bromide, or indeed iodoethane and hydrogen iodide. The reactions all look exactly the same, you're just replacing different halogens with each other. Okay, so maybe now's a good time to have a go yourself. Now what I'd like you to try and do is write the symbol equation for the reaction of methane with chlorine, ethane with bromine, and propane with iodine. Okay, I'll go through the answers now. So methane plus chlorine gives us chloromethane and hydrogen chloride. Then we had ethane, C2H6, reacting with bromine, producing bromoethane and hydrogen bromide. And then, of course, propane, C3H8, reacting with iodine, produces C3H7I, iodo-propane, and hydrogen iodide. Okay, so how does this typically get examined? Well, you could just be asked to define saturated or unsaturated. And you'd be referring to, of course, alkanes or alkenes. Now, obviously, we'll cover alkenes in a later video. However, it's important to note this here. You might be asked to name a molecule. You could be given a symbol equation, or a displayed formula, or a structural formula. And you'll need to count the number of carbons. You'll look for the fact that it's all single bonds, and then you'll put your prefix with your suffix to get the name. You could be asked to draw butane, for example, in which case you'd see that it says bute, which of course means you've got 4 carbons, and the ane tells you that it's an alkane, in which case you'll draw 4 carbons with 10 hydrogens. Now, you could then be asked what the general formula of an alkane is, in which case you would just write CnH2n plus 2. Note that the plus 2 actually comes from these 2 hydrogens on the end. Now, finally, you could be asked to write a symbol or a word equation for the reaction, for example, of propane and bromine like we just did. Thank you for watching Cardinal Science. This has been the video on alkanes. Look out for further videos on organic chemistry coming soon. If you found the video helpful, please like and subscribe. If you have any thoughts or comments, please do so down below. Thank you.